First we have the gas coming in from the gas jet. That's methane gas, and one of the things that we'd want to know about that methane gas is how much energy is there in each amount of gas that's burned. The gas is a source of potential energy stored in the chemical bonds of the methane gas is released when it's converted into heat in the combustion reaction. Now that energy then, that heat energy is going into the can, and as the can, which is made of steel, gets heated up, inside the can there's some water. And then the water particles, since they're being heated up and energy is being added, they start to move faster and faster, and they become steam. And the steam is pushing through a little hole up here, and then that steam is pushing a turbine made of some metal that was bent, and then as it spins, this part right here is an electric motor. When you put electricity into a motor, it makes the motor spin, but when you spin the motor, electricity comes out. You run the motor in reverse, it's an electric generator. And that electricity is going down here to this meter so that I can find out how much energy is being produced. Okay, what I want to show you is how to make the turbine, the part that fits on the motor generator part, to get the power from the steam to spin the generator to make electricity. And I showed you these before. These are all different models that students have made in the past, and the differences between them might be their size. They could be small or they could be large. Other differences might have to do with the number of blades that they have. They could have many blades or they could have few. The blades can be turned to the side, kind of bent to make a little scoop, or they can be left flat. The blades can be thin or the blades can be wide. So there are a number of different design elements that you can include, which you think is going to do the best job of catching the steam so that you can get the most power into the rotation of the generator. So here I'll show you what are the basic construction techniques. I'll give you some pieces of aluminum. It's not too thick so that you can cut it with a scissors, and a couple of cups so that you can draw round circles. So for example, if I wanted to make one that was this big, I could put the cup on here. I want to make sure to get it centered, because if my turbine is lopsided, it's going to turn unevenly, and that will be inefficient. Some of the energy is going to be lost if it's not perfectly round. So you want to get it as round as you can. Line up the center of the circle through the cup so that it looks like you're going to get right in the middle, and then use a marker to draw all the way around to make a circle that you can cut out. So that's one step. You make a smaller circle if you want by using the other side of the cup. So here's one size circle that you can make. You can make that size circle, or you can make a smaller circle using the other side of the cup. You can use a smaller little cup too. This one's not clear, so it's a little harder to see through. You got to line it up real carefully. If you don't like what you did on one side, just flip it over to the other side, and you can try it on that side too. So once you have made the circle size that you want, then the next thing that you want to do is you want to make some guidelines for cutting the blades, and you can do that using a ruler. One way to do that is to put the ruler down. Make sure that the ruler goes through the center of the circle so that it's nice and even, so that when you cut out the blades, they're all balanced. So I'm going to just make a line going all the way across, and then I'll turn the piece or turn the ruler, and I'll do the same thing. I turned it kind of at a 90-degree angle so that I could make it as even as possible. You don't have to do it that way, but this is one way that I can make sure I've got an even number of blades. Every time I do this, I'm going to try to get it right in the middle of the arc that I just made when I drew the first line and the second line. So I'll keep going around like that. I could make 6, or I could make 8. I can make however many I want. This is how many I decided to make for this example. And so then after you've drawn the blades that you want to cut out, then you can cut them out. But make sure to be careful when you cut them out. I've drawn these lines all the way to the center. You don't want to cut all the way to the center, because what you're going to be doing is you're going to be attaching this to a motor by fitting it over a rubber stopper, and you don't want this to go all the way to the center, because then it'll fall off. You don't want to cut it all the way in there, because then it'll just come apart. So you want to stop your cut somewhere before you get to the middle, so you might want to just draw a little guide about how far you're going to cut in. You don't want to cut any further than that, because then it'll come apart. So here's an example of what I did so far on this one. I cut in those lines that I drew, and I stopped right here, the stop line that I drew. And now I've got, on one side here, I just left them the way that they were, so they're kind of, I don't want to say trapezoidal, they're kind of wider on one end and thinner on the other. On this side over here, what I started doing was I started cutting them in to make them thinner. So I could either make them thinner like this, because maybe that'll save weight, and if it's not as heavy, it'll spin faster. Or maybe I want to keep the blades wide like this, because then if they're wider, maybe they'll catch more steam and get more of the power that way. These are different design elements that you can try. Once you've cut out the blades, then what you can do is you can turn them sideways. They're turned sideways like this so that they can catch more steam. Because if you try to blow the steam across them like this, there's not much of an edge or a flat surface to catch the steam. The steam doesn't have much to hit. So to turn them sideways, you can use tweezers. And if you take the tweezers and just turn the metal, it's not very hard to turn. You can just bend it sideways. Now you might see that the metal starts to tear and rip. You don't want to turn this so far that it rips right off. So if I started turning these all the same way, so they're all pretty even, and I want them all to be as parallel as possible so that everything is nice and balanced, so I can continue to do that all the way around the model. So if I continue to do that all the way around the model, then I'll have a bunch of even blades. Now once the blades are turned, you can make them bent. If you want to bend them like this to make them more scoopy so that they can catch more of the steam that way, maybe. Whatever you think is the best way to make your blades look. So here are some wide fat blades that are turned sideways to be kind of scoopy, but you do want to be careful that you don't twist them all the way off. I see one of mine is a little bit delicate there. So when you've figured out how you want your blades to look, and you've cut them out, the metal's not that difficult to cut. You can even cut them shorter if you like. If you don't like the length of your blade, you could just go around and say, okay, you know what? I think what I want to do is I want to make them only half as long. So I'm going to go through and I'm just going to cut them in half, and then I can make it smaller. Maybe a smaller one, although the blades aren't as big and might not catch the steam as much, would be lighter and maybe spin faster. Once you've figured out how you want your blades to look, you can test them by putting them on one of the motors. There should be a motor at your bench. And then there's some straws. You can take a straw and you can blow. See if you can get it to spin. And what you want to look for is wobble. If it's wobbly, then that's not going to be a very efficient transfer of your power into the motor. And if it's even, you want to check and see when you spin it, does it wobble back and forth? So try getting it to go. That'll give you a sense too of how hard it is, how much pressure you need in order to get this thing to spin. Give it a try, and then at the end of the hour we'll put these in a bag for your group so that tomorrow we can test it out by boiling water in the can and forcing some steam through a little hole and seeing how fast you can get yours to go.